This lesson is the first in a series about the X-ray circuit, and we'll be talking about the primary circuit. The complete X-ray circuit is actually 3 combined circuits: the primary circuit, the secondary circuit, and the filament circuit. Each of these circuits supports the process of X-ray production in different ways, and this lesson is about the primary circuit. We call this the primary circuit because this is where the main power supply comes into the X-ray machine. Another reason we call this the primary circuit is because it's on the primary side of the Stepup Transformer. The primary circuit contains several important components. One of the most important parts of the primary circuit is called the circuit breaker. The circuit breaker is one of the first components in the circuit because it protects the rest of the circuit. The purpose of the circuit breaker is literally to break the circuit and stop the incoming electrical power from moving into the X-ray machine. So why would we ever want that to happen? Well, normally we don't want that to happen, but if the X-ray machine tries to draw too much power, the entire circuit could be damaged. The circuit breaker breaks the circuit before the rest of the circuit can be damaged by the extra electrical power. The rest of the primary circuit relates to the primary exposure factors, especially the kVp. The electricity coming into the X-ray machine is 220 volts, but that's not enough to make an X-ray. In radiography, we need to use more than one voltage setting, and we need kilovolts, not just volts. When the technologist sets the kilovoltage potential, that's the kVp, this change occurs in the circuit through a device called an auto transformer. Without the auto transformer, we wouldn't be able to change the kVp to different settings. The auto transformer uses a single coil of wire and a process called self-induction. And this makes sense since the word auto means self or one. The auto transformer sets the kVp using one coil of wire through a process called self-induction. There are 2 components that follow the auto transformer: the kVp meter and the exposure timer. The electricity on the primary side of the circuit is still in volts and not kilovolts, but there's a reason that we place the kVp meter here. It's pretty simple. Volts are easier to measure, and the reading can be easily converted to kilovolts. The exposure timer is placed in the primary side of the circuit to control how long the exposure stays on, and this makes sense. Since the primary circuit controls the kVp, it makes sense that the exposure timer needs to be in the primary circuit. The last component of the primary circuit is what we call the Stepup Transformer, or technically the primary side of the Stepup Transformer. Up until this component, the electricity is still in volts, but we need the electricity to be in kilovolts. The Stepup Transformer increases or steps up the voltage from volts to kilovolts. A step-up transformer uses a process called mutual induction. And that makes sense too, because if you make a mutual decision with someone, that's a decision between 2 people. In this case, mutual induction is made by a set of 2 coils of wire, the red coil and the blue coil. Something else to notice is that the second set of coils, the blue coil, has more turns than the first set. This tells us that we are stepping up the voltage to kilovolts. The area between these 2 coils serves as the division line between the primary and secondary circuits. So that's an overview of the primary circuit of X-ray machines. The primary circuit receives the main power supply, and it also contains several components related to the voltage. The primary circuit includes the circuit breaker, which helps to protect the machine. The primary circuit also includes the auto transformer that we use to select the desired kVp. Also, in this part of the circuit is the kVp meter. Included in this part of the circuit is the exposure timer. And lastly, the final part of the primary circuit is the step-up transformer that changes the electricity from volts to kilovolts.